So now we're going to move on to section 1.4 and take a look at these things called one-sided limits and talk about the formal definition of what it means for a function to be continuous. And what we look at in this section will be the language that we need for understanding how to make sense out of jumps that we have on our graph. We're going to start by dealing with one-sided limits, and I'd like you to take a moment, pause the video, and copy down that graph that you see, that graph that has a jump, and we're calling this thing f of x. I want to talk about the limit as x approaches c, but I just want to approach c either from the left of c or from the right of c. If we start by talking about the limit as x approaches c from the left, let me write that down. The limit as x approaches c from the left. The way I'm going to write this out is I'm going to say the limit as x approaches c, little superscript negative up there, which means from the left of f of x. Okay, so I'm approaching c, but only from the left direction, not from the right direction. And as I approach x equals c from the left, it looks like my y values are getting really close to 1. So I'm going to say that that limit equals 1. Similarly, we can talk about the limit as x approaches c from the right. The limit as x approaches c from the right. My notation is going to be the limit as x approaches c from the right. I'm going to show the right with a little superscript plus over there of f of x. And now if I take a look at my function as I'm approaching c from the right, well, from the right side, looks like my y values are getting close to a y value of 4. I don't care that this one happens to be an open circle and this one happens to be a closed circle. That has nothing to do with our limit. Remember, the big idea with limits is we care about what happens as we get close to that x value, but I don't care about what's happening right at that x value. So we have our first two one-sided limits. Now, if we were to look at the limit as x approaches c in general of the function, this goes back to what we did in the first video when we started talking about limits. For this limit to exist, we have to approach the same x value from both sides. And well, I already know from this work over here, I'm approaching 1 from one direction, 4 from the other direction. That's not going to work. This limit does not exist, just like it didn't exist on the first day that we talked about this. Even though the limit doesn't exist, though, I can still talk about two one-sided limits that themselves do exist. I think I do want to make a note of something. For an overall irregular limit to exist, the left and right limits must exist and must be equal. For an overall limit to exist, the left and right limits must exist and be equal. So that limit that I gave you over here couldn't exist because I was approaching different values from the left and from the right. For an overall limit to exist, the left and right limits must exist and be equal. If you need another moment to finish taking notes, please make sure you push pause. Otherwise, we're going to go and we're going to take a look at the section 1.4 one-sided graphical and numerical limits worksheet. I would like you to take a few minutes, pause this if you're on YouTube. If you're on Edpuzzle, it will automatically pause. And I'd like to see what you can do with some graphical limits on the top and numerical limits on the bottom. So let's take a look at these. Letter A, the limit as x approaches 0 from the left, is, well, here's x equals 0. As I approach from the left, my y's are getting close to -1. In letter B, I want to do the limit as x approaches 0 from the right. Well, as I approach 0 from the right, my y's are getting close to a y value of -2. Because letters A and B did not agree, this overall limit does not exist. I have to approach the same x value from the left and from the right for that limit to exist. Letter D, the limit as x approaches 2 from the left. Well, as I approach 2 from the left, my function is approaching a y value of 2, so that limit is 2. Letter E, as I approach 2 from the right, my function's approaching a y value of 0. Again, because my limit from the left of 2 and limit from the right of 2 didn't agree, the overall limit does not exist. It doesn't matter that they kind of filled the function in over here. The limit doesn't exist. However, going on to G, f of 2, remember the f question is what's going on right at x equals 2. So I ignore everything else. Right at x equals 2, my y value is 1. So f of 2 equals 1. Letter H, the limit as x approaches 4 of f of x. Well, there's no difference as I approach 4 from the left versus 4 from the right. They're both approaching a y value of 3. And since they agree, my overall limit is also going to be 3. Number 2, trying to figure this out from a table. So I have some function over here. We're not going to worry so much about that formula. But in letter A, I want to figure out the limit as x approaches 2 from the left of my function. I don't care about what's happening right at x equals 2. I'm going to cover that up. As I get close to 2 from the left, I'm approaching from this side, -3.8, -3.98, -3.998. Looks like my y's are getting closer and closer and closer to -4. And that's what I'll say that limit is. As I approach 2 from the right, well, as I'm getting closer and closer to 2 from the right, -2.99, -2.999, -2 a whole bunch of 9s, look like those y values are getting closer and closer to -3. So what's my overall limit? No, I can't do this because I'm approaching a different value from the left versus the right, so that overall limit does not exist. What's f of 2? What's going on right at x equals 2? Well, f of 2 is going to be -4 because I don't care about anything but what's going on right at x equals -4. What's happening on the graph? Well, let me try to sketch a little bit of what's happening here. Let's see. As I approach x equals 2 from the left, my y's are getting closer and closer to -4. So kind of like this. As I approach 2 from the right, my y's are getting closer and closer and closer to -3. And then right at x equals 2, my y is -4, so I'm going to fill it in like that over there. I have a jump going on the graph. And I think that's all I have to say about this.